is Narendra Kumar Dwivedi welcoming you all in the next lecture of Numericals on electric dipole and torque on dipole। तो ये दो टॉपिक के न्यूमेरिकल हम आज के लेक्चर में कवर करेंगे। तो सबसे पहले हम क्वेश्चन लेते हैं। सबसे पहला, द बॉब ऑफ अ सिंपल पेंडुलम हैज अ मास ऑफ 40 ग्राम and a positive charge of 4 into 10 power to minus 6 coulomb. It makes 20 oscillations in 45 seconds. A vertical electric field pointing upward and of magnitude 2.5 into 10 power to 4 Newton per coulomb is switched on. How much time will it now take to complete 20 oscillations? So for the first question, what are the informations given? Given mass of bob 40 gram. Let's convert it in kg. 40 into 10 power to minus 3 kg. Now what else? Charge is 4 into 10 power to minus 6 coulomb and 20 oscillations, time for 20 oscillations. 20 oscillations, it is 45 seconds given. Now vertically acting electric field 2.5 into 10 power to 4 Newton per coulomb. Now we need to calculate time to complete 20 oscillations. So let's have the solution part. So here we first now calculate, since time for 20 oscillations 45, therefore time for one oscillation, that will be the time period, it is 45 upon 20 second. So this is now the time period. Thereafter we write when no electric field is applied, then time period we have t equals to 2 pi under root L upon G. So this is our formula. Now hereafter what do we do? We now just have this 45 by 20 as time period. 45 upon 20 equal to 2 pi under root L upon G. For the sake of simplicity we are taking 10. Now hereafter just having square on both the sides. So simply having the simplification of this, 45 upon 20 square into 1 upon 4 pi square into this thing, this 10 goes there in multiple into this 10. So this way we have the value of L coming out to be, it will be just around 1.2836. So this is the value of length of the pendulum when no electric field is applied. Now let's have the application of electric field and see what happens. Now when the electric field is applied, then we have time period to be equals to 2 pi under root L upon G minus A. Now here we must know the value of A. A is the acceleration acquired by or gained by the bob due to the application of this field. So that A will be where A is equal to F. F was QE upon mass of the bob. So just placing the value, charge is 4 into 10 past 2 minus 6 into electric field is 2.5 into 10 past 2 4 upon, now mass of bob is given to be 40 into 10 past 2 minus 3. So this acceleration will be getting 2.5 meter per square second. So this is the value of acceleration. We have G to be 10. So this way L is 1.2836. Just simplifying it, T equals to 2 pi under root 1.2836 upon, it's 10 minus 2.5. So this thing comes out to be around 2.598 second this comes. So this is actually the time period of one oscillation. Now if we just multiply it by 20, so we'll have the time period for 20 oscillations. So let me just make the space here so that we can continue. Now simply we can have the time period for 20 oscillations equal to 20 into the time period of one oscillation, 2.598. So this now comes out to be around 51.96 second. So this is the value that we'll be getting as the time period for 20 oscillations when that electric field is applied. Okay, so let's move on to the next question. Second question will now be having. So second question I'm just reading out. Let me make first some space to write on. So here we have second question. Two particles have equal masses of 5 gram each and opposite charges of 4 plus 4 into 10 past 2 minus 5 coulomb and minus 4 into 10 past 2 minus 5 coulomb. They are released from rest. Initially they are at rest with a separation of 1 meter. Initial separation between the charges is 1 meter. Between them, find the speeds of the particles when the separation is reduced to 50 centimeter. Just half they have come closer. At that condition, what is the speed gained by the particles? That is the question asking. So let's have second question solution. So here given information is what? Mass of particles is equal to 5 gram, which is 5 into 10 past 2 minus 3 kg. Now thereafter charges plus minus, one carries plus, the other carries minus, 4 into 10 past 2 minus 5 coulomb, and thereafter initial separation between them is of 1 meter and final separation is 50 centimeter. That's 0.5 meter, half meter. So at this separation we need to calculate the distance. Okay, so let's have solution part. So we first now calculate the force that acts when the charges are at 1 meter separation. So this is K, K value 10 past 9 into 10 past to 9 into Q1, Q2, that's both are of same value. So we'll have 4 into 10 past to minus 5 square, Q square upon distance square. Distance is 1 meter. So we have 1 square here. Now having just solution of this, we'll be having 14.4 about Newton. So this is the value of force that we'll be getting. Now due to this force, what is the acceleration gained by the particle when allowed to move from rest? So let's have acceleration now. So A equal to F by M, and that is equal to 14.4 as the value of F upon mass is given to be 5 into 10 past to minus 3. So just solving it, will be getting 2880 meter per square second as the value of acceleration with us. Now we can simply apply what? The third equation of motion. So we have v square, which is equal minus u square, which is equals to 2a into s. Now u is given to be 0, so it is taking root now over a is 2880 into this distance is given to be 0.5, final distance, final separation between them. S is 0.5. Now a value is 2880 and this is 2. So just solving it, we'll get the value of V to be 53.66 meter per second. So this is finally the value that we'll be getting for this solution of this second question. Now let's have third question. So before that, taking question, let me make some space so that we can write here. So the third question we'll be taking now as two particles carrying charges minus q and plus q and having equal masses m each are fixed at the ends of a light rod of length small a to form a dipole. Now the rod is clamped at an end and is placed in a uniform electric field E with the axis of the dipole along the electric field. The rod is slightly tilted and then released. Neglecting gravity, find the time period of small oscillations. So this is the question now. So here let's have solution part. So what are the given information here? Given two particles carrying charges on particles equal to plus minus q. Magnitude is equal and one is plus and the other is minus q. And equal masses, small m mass is given, and they are fixed at the ends of a light rod of length a. So length of rod forming the dipole a. So these are the information given. Now the rod is clamped at an end and is placed in a uniform electric field. Electric field is given to be E. So now let's have the solution part of this question. Here actually the information we need, these are the information given, and the information that question is demanding from us as an answer It is the time period of simple small oscillations we need to calculate. So let's proceed. Now the time period t equals to 2 pi under root L upon G. So this is actually the time period initial that we know. Now the force experienced by charges. So what will be the force when this dipole is placed in uniform electric field? So that force will be plus minus QE. So we simply write down magnitude as QE. Now acceleration equal to force upon mass, so QE upon M simply. Now here what do we do? Now we write the value of time period now. So the time period equals to 2 pi under root L. Actually here length of the dipole is given to be A. So this is the value of L that we'll be placing here. So this is A as L upon G. Instead of G we take this acceleration. So this is a QE by M. Now finally we have 2 pi under root MA upon QE as the final answer. So this is the here don't make any confusion. A is here the length of the rod, light rod, which is forming the dipole. It's not acceleration. So it is MA upon QE as the time period that question is demanding from us. Now let's have next question. So the fourth question we are taking now. So the fourth question is an electric dipole of dipole moment. I'm writing now the dipole moment. Vector P is 2 microcoulomb meter I cap plus 3 microcoulomb meter J cap minus 1 microcoulomb meter K cap is placed in a uniform electric field. Electric field is also given here. Electric field is 3 into 10 powers to 5 Newton per coulomb I cap plus 2 into 10 powers to 5 into K cap. Actually I must write Newton per coulomb as well here. K cap. Calculate the magnitude of torque that E exerts on P. So tau magnitude we need to calculate, mod of tau. That needs to be calculated. So this is the information given. Now tau we must find first vector tau as the cross product. So for that we must have determinant now of 3 cross 3 order. So here P cross E. So we write now 2 into 10 powers to minus 6, 3 into 10 powers to minus 6, now minus 1 into 10 powers to minus 6, and E. E is 3 into 10 powers to 5. J cap is missing, so we write 0 here under J cap column. Now here 2 into 10 powers to 5. So now let's have the solution part of this. So here it is I. Now 3 to the 6, 0.6, this one, minus 0, minus J cap. So this is 2 to the 4, 0.4 minus plus 3. So this is 0.3 plus a cap. Now it is 0 minus. It is 3 3s are 9. So this is 0.9. So we now have 0.6 I cap minus 0.7 j cap minus 0.9 k cap as vector tau. Now to have the magnitude of it, we need to have this mod of vector tau equals to under root, this is 0.6 square plus minus 0.7 square plus minus 0.9 square. So when you solve it, you'll get approximately 1.29 Newton meter as the final outcome. So this is the magnitude of tau. Let's have the last question. So we have now fifth question with us. And that is, let me make some space. Okay, so the last question is, an electric dipole of length 2 centimeter is placed. Here what is given? Electric dipole length, generally we take it as 2a, which is given to be 2 centimeter, 2 into 10 power to minus 2 meter, is placed with its axis making an angle 30 degree. So theta is 30 degree to a uniform electric field. So electric field is given to be, it's 10 power to 5 Newton per coulomb. If it experiences a torque is also given. Torque equals to 10 root 3 Newton meter. Calculate magnitude of charge on dipole. So charge on dipole we need to calculate. So let's directly proceed. As we have formula with us, tau equals to P E sin theta. For P we are writing Q into 2a into E into sin theta. So this is the formula that we have. Now place the values. 10 root 3 is the value given in question of tau. Q is to be calculated for 2a dipole length, 2 into 10 power to minus 2. E value is given to be 10 power to 5 and sin it is 30. Sin 30 is half. So this way when you solve this, student, you'll get value of Q to be it's root 3 into 10 power to minus 2 coulomb. So this is the value of charge on dipole. So with this we end up today's lecture. So students, I hope you have enjoyed. So do like and subscribe to the channel.